Hello everybody, my name is Joel. Today we are going to see the maths in C++. So before we start writing code in the maths of C++, we first need to keep the header file called as Cmath. The Cmath means this is a header file for calculations, and we need to check for the symbols out. So this is the addition, the old regular, the subtraction, the old regular. Now the multiplication is a little different. It's not this, the x. Instead, it's the star. And next, the division is also, the division is like the slash. And we have something called this modular operator. This operator will give the division remainder. So the modular operator. So we're going to check these out in action. So first we're going to create two variables. And we're going to give them a meaningful name A and give them 1 and integer B equals 2. And we're going to create another integer called Z. But instead of giving this a value, let's change this A value to 10. That's a better one. Instead of giving Z a value, let's try to ask C++ the addition of the sum of 10 and 2. It's going to be so easy. We're first going to keep. So after writing Z equals, we're going to write A plus B and semicolon. So C++ is going to print. Let me tell you how this all works. So I have a variable called A and B. The value of A is 10. The value of B is 2. Now I have another variable called Z. But instead of giving this a value, I asking C++ the value of Z is A plus B. Which means it's going to take the number, the value of A and B and give the remainder. So if I go to my, so now I'm going to print out here Z. Because the variable is only printing, is going to add A plus B and print it out. So if I go to my console, it prints 12. Not only addition, as I said, there is subtraction, and my console is going to give the now 8. Multiplication, division, and modular operator. So we saw now that C++ had 5 operators. So as an exercise, I want you to do the addition of 10,223 plus 899. This is super simple and beginner friendly. So let's check your answer. Spend a couple of minutes on this and check out my answer. So it's answer time. So 1020. So zeros 23 and 899 and the sums means addition, and it's gonna print out 10,922, which is the correct answer. So now now we saw maths in C++, but what about square roots, cube roots? We're also going to see this in C++ right now. So these are the basic mathematical functions. SQRT means it computes the square root of x. CBRT in braces x computes the cube root of x. POW in braces x comma y computes x raised by the power y. EXP slash in braces x computes the exponential functions divided by only these, sorry, the extra ones here. E at the top, x, and log x computes the natural logarithm base e of x. Log 10 x computes the base minus 10 logarithm of x. So these are some functions, and we want to see them all in action in programs. So let's see. Here I have a basic mathematical program. This program shows the square root of 25. So let me explain the program. Here I have a variable called number, and the value of it is 25, and it's printing out the square root. So the square root equals, and I write the square root function and the number in braces. And now it's gonna print the square root of number is square root function is gonna have an std. So let's see this on my console. It prints square root of 25 is 5. Okay, how about not 25? How about we check another value like 15? That's a better idea. And it prints the square root of 15 is 3.87298. Great. Let's check cube root. Cube root is so easy. We just needed to take off all the square roots and instead write cube root. Not SQ, here CB. Cube done. Now it's gonna print out the cube root instead of the square root. The cube root of 15 is 2.46,621. Great. Now how about we check the others also with the program examples. How about we check the power example. I'll explain the program. I again have one more variable called base, and the value of it is 2.0. And next I have one more variable called exponent. The value of it is 3.0. And next I have a variable without any value, and that's the result variable. They are all doubles. And the next, here's the code for making the exponent use power base exponent using the power function. So we write result equals power base comma exponent, and down I write std cout base raise it to the power of exponent is result std end line. So and down return 0. So I'm going to go to my console, and it said here it is. It's 2 raised to the power of 3 is 8. Great. How about we change the numbers? How about let's keep 4.0. Yeah, let's keep 3.0. It's gonna print now 4 raised to the power of 3 is 64. Great. So this is the power function in C++. Now you want to check next the logarithm exponential function. Here I have code for the exponential function. So let me explain the code. I have a variable called x and an exponential value variable, and it's performing exponential, and the x, the variable e, and it's printing out e raised to the power of x is exponential value std end line and return 0. So let's go print it out, and I get e raised to the power of 2 is 7.38,906. So how about we change the value? Let's keep it 3.0. Let's see what will happen. The value will change. E raised to the power of 3 is 20.0855. Great. So that is the exponential function. Now you're going to check the logarithm function. Here I have the code for the natural logarithm function. So for as usual the Cmath, and we create a variable called x, and it's the 10, and the value of it is 10.0, and we created another variable called natural log, and the natural log variable is performing the logarithm function, and I used the snake case for the natural logarithm function, and we printed out natural logarithm of x is natural log, and it's printing out the natural log function here on my 6th line and std end line. So let's go to my console, and it prints natural logarithm of 10 is 2.30,259. Great. Let's change the value again. How about this time? Let's keep 20. That's better. The natural logarithm of 20 is the difference. So now let's check the 10 one. This is also so easy. So here I have a program for 10 log. I include the Cmath function, the Cmath header file, and I created a variable called x, and its value is 100.0, and log 10 is the snake case here also for the log 10 value, and it's performing the log 10 for x, and double 0.0 multiplied log 10 value. So next I am printing out 10 log 10 x, the value of x equals result, and result is the value which the function which performing it. There we go. It prints 10 star log 10 100 equals 20. So great. So now we're going to check the trigonometric functions. Of course there will be trigonometrical functions also. So let's check it out. Here these are the trigonometrical functions. Now you want to see them in action. So here I have code for calculating the angle, the sine, the cosine, and the tangent of a triangle. I am giving a tour across. So first I enter the angle degrees, the angle radian, and this all converted to degrees to radian. All these it may seem big, but it's simple to be understood. You just need to have a little practice and you're going to be super simple. So let's go to my console and run it, this whole program. There we go. For angle 45 degrees, the sine theta is 0.7707. The cosine theta is 0.70107 and the tangent is 1. So this is the trigonometrical functions. You want to check some more, but that's the end, like this end of the trigonometrical functions. You want to see this, but before we stop the trigonometrical functions, let's see how our basic mathematical functions with trigonometrical function. This is going to be interesting, right? It's going to really be interesting. So this whole program is also a trigonometrical and a basic mathematical function. So let's go to our console and run it. So here's the answer. For a right triangle with base equals 3 and height equals 4, hypotenuse 5, area 6, for angle 30 degrees, sin theta 0.5, cosine theta 866,025 and tangent theta 0.57735. So this program which you are seeing here did this all. Let me explain you the program. So first I have a couple of variables and the variable name is base, height, angle degrees, angle radian. The base, I set the base to 3.0, the height is 4.0, angle degrees 30.0, the angle radian equals angle degrees multiplied MP by pi 180, convert degrees to radians. So next this here is for calculating the hypotenuse using the Pythagorean theorem. So double hypotenuse equals square root power base comma 2 plus power height comma 2. Next, calculating the area of the right triangle. Double area equals 0.5 multiplied by base and multiplied by height. Calculating sine, cosine and tangent of the angle. Double sine value equals sine, angle radian, double cosine, cos theta, angle radian, double tangent value, tan theta, angle radian. Next, the output result. STD Cout for a right triangle with the base equals base and height equals height. And colon. And next, hypotenuse. STD Cout less than and in parentheses hypotenuse colon less than hypotenuse less than STD end line. Next, STD Cout less than and in parentheses in double quotes area colon less than area less than STD dot end line. And STD Cout sine value less than STD end line, HED Cout cosine value less than HED end line. HED Cout less than and in double quotation marks tangent value HED colon end line. So this is the trigonometrical functions with the basic mathematical functions. And as you all know, the output is for a right triangle with base equals 3 and height equals 4, height hypotenuse colon 5, area colon 6, for angle 30 degrees colon sine colon 0.5, cosine colon 0.866025, tangent colon 0.57735. So this is the basic math combined with the trigonometrical math. So now I have the rounding and remainder functions. The first one is ceil and embraces x. It returns the smallest integer greater than or equal to x. Now floor embraces x. Returns the largest integer less than or equal to x. Round embraces x. Round x to the nearest integer. And trunk embraces x. Truncates the x towards 0. So now we want to see these all in action in the Cmath libraries. So here I have a program for ceil. Let me explain you the program. So first I have a double called x equals 4.3, double y equals minus 6.7. They are all variables, and next down also we have two more variables, but instead of giving a value, these variables contain the functions for performing our calculations. Next, the output results. Now this prints all the results in our program. So let's compile it and check it on the console. Now a C++ program gave ceiling of 4.3 is 5. Ceiling of minus 6.7 is minus 6. So this is a basic program on ceil. Let's change a couple of things. Let the basic one. So we want to change. How about we change it to 6 and keep this to 7. This will be interesting. So is 8 minus 6. I like it. Okay. I like this ceil function. I'm like a big fan of this function. So now we're going to check the next function. And that's the floor function. So here is an example for the floor function. I created two variables called as x and y. And the values of x is 4.3. The value of y is minus 6.7. And now down we have double floor. X, I use the snake case for both floor x and floor y. Floor embraces x and floor embraces y. Floor of x is floor in snake case x. Floor of y is write it in snake case floor y and return 0. Let's compile it and see the output in the console. Here we go. Its floor of 4.3 is 4. Floor of minus 6.7 is minus 7. Great. So we got the output. This is the floor function. And next we will check the other two functions which we have in the rounding, the remainder. So next we are checking the round function. So here I have two variables called as xy and the value is 4.36 and y's value is x.7. To calculate the round values, I give rounded x, rounded y variable names in snake case equals round in braces. I kept x and for round y in braces. So at last I need to print out round value of x is rounded x STD and line. Rounded value of y is in rounded y STD and line. And let's go to my console and run it. Great. Here we go. It gave the answer. Rounded value of 4.3 is 4. Rounded value of 6.7 equals 7. Great. Now we are going to check the other things. So here I had a code for the trunk function. So first again I created two more variables, and that's x, y, and the value of x is 4.3. The value of y is minus 6.7. Double truncate, and in snake case I wrote both truncate x and truncate y, and these perform the calculations, the trunk x and trunk y. And last but not least, I made the cout std. I took from the standard library cout and printing out the answer. And let's go and compile it on my console, and there we go. It gave us the output. Truncate value of 4.3 is 4. Truncate value of minus 6.7 is minus 6. Great. So this is the truncate value. We want to check other functions of the Cmath. So let's go check it out. We also contain the other functions like the ABS. It's computing the absolute value of x. FNOD x comma y computes the remainder of x divided by y. And hypot x comma y computes the hypotenuse square root and plus y up square root of 2 and division of both of them. So I want to check all of these in action in Cmath libraries. So here's the code for the ABS, and I created a variable called n1 and a variable called n2. The value of n1 is minus 5. The value of n2 is minus 7.5. Now again, for calculating the absolute, I created two more variables, ABS n1, ABS n2 in snake case, and there now ABS n1, ABS in braces n1 and FAPS in braces n2. So, and last but not least, I'm printing out everything. So let's go check this out in C++ in our console. And this is absolute value of minus 5 is 5. Absolute value of 7.5 is 7.5. Let's take the mod function in C++. So here I have the mod function. I have two variables, and that's x, y. I gave them values, and I made to calculate the remainder of mod. Double remainder equals mod x comma y. And last but not least, I'm printing everything out, and let's go check it out on my console. Yes, here's the answer. It's remainder of 10.5 divided by 3 is 1.5. Okay. And last but not least, we are going to see the hypot function in the other function. So last but not least, I have the hypot function. This is for the hypotenuse. Let me explain. I have side 1 and I had two variables called side 1 and side 2, and down I kept another variable called as hypotenuse, hypot, side 1, side 2, and and last but not least for printing of everything. Yes, great. Now last but not least, we are going to check the increment and decrement operators. This is increment and decrement. This is so easy. This is just incrementing and decrementing an operator. Let me show you an example. So here I have a variable called a, and I gave this the value 11. Down I wrote a plus plus. Now we can write this a plus plus, either the prefix or the suffix. There's no right or wrong here, but here's the thing. When I use a plus plus, it means that I'm incrementing this. As I said in my video, C++ means the increment of C programming language, and like that, a plus plus means the increment of the present value that our variable is holding, which means now instead of 11, 12 is gonna appear, and I'm sure about it. As I said, 12 appeared. Now let's keep this in the prefix. There's no change. It's 12. So now what is the decrement operator? It is just the side. It's the subtraction. So it's going to be subtracted. The 11. It's 10, and I can also give this, as I said, on the prefix. Now we don't have multiplication or division like these. Only we have addition and subtraction. Now as an exercise, I want you to build a basic calculator. It's very small. It can be whatever you want. As just all the exercises which I'm going to do, as this also contains an exercise, and just to build a basic calculator. And I also going to show you. So since it's going to be more than 30 minutes, I'm just asking you to build a small calculator, whatever you want, and I will also build a small calculator. So work on this project for a couple of minutes, and if you can't do it, it's okay. Remember you're the student, and if you learned it, then one day you're the one who's going to be teaching it. So let's do it, a calculator. So this is a basic calculator, but later in the course where we know more about like if statements, loops, we're going to build even more a better calculator, and we're going to learn more things. So thanks for watching this video. Don't forget to hit that like button and subscribe button. Bye bye, take care.